Hello students, in this video we are going to see the LPP non-linear programming solution using Excel solver. So in this particular book, An Introduction to Management Science by Anderson, Sweeney, Williams, Kahn and Martin, if you go to the non-linear part, right, this non-linear part, there is a problem they have explained which is called as blending the pooling problem. So blending the pooling problem, this is on page 383, uh, and in this particular uh, problem finally gives us this particular model. Now this is a non-linear model. Why? Because you will have there is the variables are not in linear format. You can see here the variables are one variable divided by addition of two variables and so on. So the variables are not in a linear format, the constraints are not in a linear format, and hence we have to use the non-linear method of solving in Excel solver. So let me take you to the Excel sheet where this particular problem of pooling problem is explained. So this is the model which I have taken it from there. So we have these variables XPR, XPP, X3R, X3P, and also we have Y1 and Y2. So these are the variables. So we have 3 and 3, 6 variables, and this is my objective function. In my first video, I have explained you how to capture these functions, objective function in your Excel sheet. So here it is captured. If you just double click, you will see the entire function 2.9 times XPR, which is C5, right? And X3R, right? X3R, this is one. So like this, we have captured the entire function here, objective function, and then we have also captured the subject to constraints. These are all constraints. So here we have captured in this particular, because there is a ratio in your equation, you have captured the ratio like this, that y1 divided by y1 plus y2 into the xpr is less than or equal to zero point 0.3 times xpr plus x3r, right? So this is how we captured all the uh, equations, the constant equations. We have 1 2 3 4 5 6 7 8 9 10 11 11 variable, 11 constraints are there, equations are there, and all these variables, we have 6 variables which we want them positive. So this is the model, and because of this ratio it becomes a nonlinear model. So when we are solving it, we will first use solver, and in the solver I have already explained you in my first video how to capture all these variables. All this the objective function is captured here, the variables are captured here, and the constraints are captured here. But when you try to, and also because we want all the constraints to be positive, we have to tick mark this. But here earlier we used to take LP, simplex LP, because we were having linear problems. Now we have this particular problem is a non-linear problem, that is why we have to go for GRG non-linear. Now when you try to solve this, I'll just explain, show it to you. When you try to solve, you don't get any equation, you don't get any solution. The solver encountered an error value in the objective cell or constraint cell. Now why this is happening is because we have this divided by 0, because solver will start from 0 0 0 0 values, and then because we wanted greater than or equal to 0. So right, so if the denominator is 0, then this will become infinity, and hence this is giving us a problem. So to solve this, we are just going to use a simple trick. We'll keep initial solution as 1 1 1 1 1 1. Anyway, this is the initial solution from where it will start uh, you know taking the values, and it will finally reach to the objective, the optimum solution, which we will see. So when we have this, now there is no divided by 0 problem here. So now we'll go for the solver, data solver, and already the setup is there, and now you solve it. Right now you see we are getting the report here, and the answer is 5831. XPR is 8000, XPP is 6000, X3R is 2000, X3P is 2571, Y1 is 5000, Y2 is 9000. 5831 is your maximum value of the function. So we'll just cross check the book answer, which is also coming the same, 5831, and these are the various values which we already got in our solvers, right? So 5831. So this is what is the how to method to solve non-linear type of problems. Thank you.